Still learning Zoom.
All right, it's recording, so take it away, Joe.
Thanks a lot for the help. Okay, folks. So last time we talked about Ironic, and Julia gave an awesome presentation. It took it a while to get into YouTube. I hope that you watched it. If you didn't attend, I think it was really interesting, and we said that we'll circle back to it later on, especially regarding the whole redfish part. But today I wanted to try and focus a bit more about the decision that we voted on a month ago, which was the host to DPU boot coordination. Let me share my screen in case you forgot. Okay, can you all see my screen?
Yes.
Perfect. So just move that aside. I did a couple of questions here, but I think we'll generate more as we talk about it. So the thing that we voted on a month ago is that we are going to do the coordination between the server BMC, basically the server, and the DPU through the out-of-band management via the platform BMC. Now, as you can see, this diagram is a bit empty, meaning that we have a lot to talk about here. One assumption that we already took is that we are not going to standardize on BIOS to server BMC communication. It's going to be out of the scope for us. That is because vendors have their own proprietary communication and we don't want to dictate that. And we created here a basic flow diagram, but I think it's pretty much covers it at the end of the day. And below that, a list of potential standards which we can use. PLDM and SPDM were, I think, the ones that we consider mostly. Does anyone else? I wasn't in the original talks when this document was created, so in case anyone else have anything else to add or another standard he wants to us to consider for the coordination between the two. Now is a good time to raise it.
Yeah. So for so I mean, I think, well, okay. So SPDM, the only reason it was brought in, I guess, is to kind of talk a little about PCIe DOE, but that's not really as a transport mechanism, but it's not really directly tied to SPDM. I mean, I don't know if there's any reason to.
I think that PLDM was the obvious candidate as well. Here, I've just listed them because they are in the document.
Yeah,
I guess someone raised them for a reason I didn't want to ignore it. But when we talked about it internally in NVIDIA, I think we both agreed on that PLDM makes sense around here. And I don't hear any objections to it at the moment.
no, there's a little more work that needs to be done because we need to come up with like standard names or whatever for the sensors, right? Sort of like the PLDM for NIC. We need a PLDM for DPU.
Mm-hmm. So actually one thing that I want to do before that, just like to review the doc, but I think that one thing that in this document that wasn't clear for me, at least when I looked at it, is that XPU management. I haven't found where we talked about what is XPU management specifically, because I think it can be a number of things.
Right. It was a placeholder for whatever terminates the out-of-band messaging to a platform BMC, right? And different architectures are going to do that differently. Right.
Okay, so whatever terminates the communication between the XPU and the platform BMC, you said. That's the definition that you came up with?
Well, yeah, it's basically what receives the message, right? So you know, you could think of you could have a soft management stack that might be receiving the packets. Now, yeah, I don't know. I mean, I don't even know if is there a conversion for PLDM to IP? Probably not, right? You can run it over USB, you can run it over I2C. You know, NCSI looks like standard Ethernet frames, so theoretically you can make kind of a software, you know, receiver of NCSI packets. So, and then, you know, we really don't say what the physical medium is. You know, another option would be even over serial, right? So you could have something sitting on the other end of a serial line, but assuming this is probably PLDM over MTCP over the I2C lines or USB.
USB.
Yeah.
Yeah.
So those are the most likely things, but something has to terminate the other end of that. So depending on a DP, you know, XPU architecture, that might be, you know, something like a smart PCIe switch. It might be some other management controller. It might be the ARMS itself. You know, there's a lot of variables.
Okay, so if it's the ARMS themselves, I'm trying to think about how it would work. I just want to write like examples for XPU management, because when I look at it, the first thing that came to my mind is the DPU BMC, which I know not all vendors use. We have it in NVIDIA, but not always. A chassis BMC, which is always an option. Regarding the actual XPU, you mean that the XPU and the XPU management would be basically unified in this flow?
Well, it'd be so. Yeah, I did not attempt to break it down because I don't believe there's no standard, right? So there's something that terminates the other side of it, right? So, you know, data sheets on different DPUs, all you know is that they implement this protocol. You don't necessarily know how.
Yeah, and
okay, that makes sense, I guess. That makes sense. Yeah, Reza?
Yes, so, you know, just to expand a little more on what Lee is saying, and to give a more concrete example, so some DPUs have a management controller, right? We've been trying to distinguish the terms, distinguish the different management controllers. So an add-in card management controller, an AMC, is on the DPU. A BMC, baseboard management controller, is in the server. And the CMC is the chassis management controller. So we've got ABC, right? And so in this particular case, we could have the AMC, the add-in card memory management controller, can be a separate physical entity, or it can be a software stack. Right. So those are the two examples.
And I would trying to dance around the issue without, you know, revealing too much architecture, just because there is a BMC on a XPU does not mean that it terminates the, it's terminating the PLDM from the platform BMC, right? BMC has a northbound IPMI interface. It doesn't necessarily have a northbound. The PLDM interface is southbound to whatever it is, right? So it's not guaranteed that you'd have a PLDM interface coming northbound. Like if you look at this as a hierarchy of management controllers, there's no guarantee that you'd be able to talk from the platform BMC over PLDM to the AMC, right? Or whatever it is.
Well, you have to have some entity that you are able to talk to. But what I get from the recent conversation is that we don't want to standardize between XPU management and XPU CPU communication. Does that make sense? Because those two can be the same entity, separate entity. They can have their own proprietary protocol to communicate with the two, and we just need to assume that this box is part of the XPU.
I should draw a diagram around that basically just kind of puts both of those in a box. This was converted from a Visio over to I think this is plant UML, and I need to go back and clean it up a little bit.
If that helps, I've been saying that to myself for the past 2 weeks that I need to clean up that that Redmine as well, and can't find the time. Generally, we need to remove we need to rephrase it. We need to say here that we devoted on option 3, remove option 2, and make sure to keep option 1 for the future, like we agreed on. Yeah, we need to clean up this page as a whole a bit. But
I guess kind of going back to what we talked about a couple of weeks ago, right? A goal would be to get this information kind of pushed through a standards body, right? I mean, is that where we're wanting to end up?
Eventually, I guess we want to take it to PLDM and make sure that we have what we want there. Oscar, I think that you or Yuval are involved in PLDM and attending the PLDM meetings.
Yeah, Yuval, he's the owner of the spec DMTF.
Okay. That's good. So we have a domain expert on the call at least.
I'm not the expert, yes, but I can. If there are any questions, I can forward that question to him.
Okay.
I just wonder if we shouldn't
dive deep enough to generate one.
I'm wondering if we shouldn't create a document under source control that we work to draft a proposal over to PLD. I mean, just working in those bodies a little bit, they usually they wouldn't necessarily be working on things like a wiki. This is kind of like editing a wiki page, whereas opposed to they would be editing a real markdown document with defects and merging and things like that, right?
I think that would be a great outcome of the general effort, to have something to push into PLDM, start working offline with them, not to standardize on it. One of the, okay, I'm jumping back and forth. So regarding, let me try at least to talk about what we agreed on so far. So XPU management, XPU CPU, we will treat them as one.
Yeah, and the FRU request, FRU response stuff, that doesn't necessarily have to be a FRU. That could be just any kind of inventory information. I mean, basically, the server BMC needs to know that there's an XPU in the server, right? It needs to know what's there, to know that it needs to hold I mean, there has to be some kind of configuration in inventory, right?
You know what? That's actually bringing me to a previous question, another question that I have regarding the power on, power off that we see here. We have a
Mhm.
lot of assumptions about that power on, power off flow. Do we always assume that the server BMC is on and then and only afterwards the XPU management and XPU CPU starts? Do we make that assumption? Because there can be situation where the server BMC and the BIOS will boot, but the XPU management or the XPUs in general will take more time to boot here. But we are already doing full request and putting
Right,
the whole
so-
enumeration at the end. So maybe we should switch the
yeah.
two a bit.
So the assumption here is that fru would be readable in VOX, right? So it would be before you even power on a particular server, right? So I mean, yeah, it would be good to probably put an assumption section above this. But
So if we are saying full, we have something concrete to work with, right? We know what we talk about. But if we are saying general inventory, it's harder to make those assumptions.
yeah, agreed.
I think we can keep, for me at least, full made sense. But we have other DPU vendors here. Anyone who wants to chip in? What do you think? Yes, no, maybe. Okay. Reza,
Well, I'll just say that
yeah.
living through the supply chain problems that we had not too long ago here, and probably still underneath, right? Mandating fru parts isn't necessarily the thing we always want to do, right?
So, for I don't know if we want to mandate certain for scheme or like well, there is the standard for the question is if we have enough there to actually recognize the XPU and consume the info, and as a server consume the information that we want from the XPU from the standard for, or do we need to I know that a lot of times people are adding proprietary stuff into their flow or like vendor specific things into their flow. And this of course can't work within and of course we can't work with that because each vendor will require its own thing, and this is exactly what we want to avoid. So maybe a good thing here is to take a look at the standard for what is given with it and see if that's enough, if it contains enough information.
Yeah, the standard IPMI fru and the LDM for fru specs.
So
I'm not saying we should do it right now, right? But this is something that we can take into the next meeting, provide the exact scheme, go over it. Let I guess server vendors, because you are the entity that will consume it at the end of the day. Circle back internally and see if there are things that are missing you for you for that initial coordination recognizing of the DPU.
Yeah, do we need to develop separate or independent flows for XPUs with and without the fru capability?
Maybe, and at a really high level, I think this could be optional because you could configure and and say, hey, I just want to blindly hold on this slot. I know what it is. You don't know what it is. The customer could configure the system, say, I expect the DPU to be in this slot, you hold, right? Even without knowing what's there, right? So while it would be, I think it's it's a good thing to have, but it may not be absolutely required to make this work.
I'm kind of concerned by any assumption that a customer would need to configure something in the system itself for it to be aware that something's there. Just speaking out of practicality with customers, they will always try and just throw things in the machines. And somehow maybe it's if it can discover it and know it's there. I don't know. I'm out of my depth on this topic. Just I know from a practicality standpoint, people will. I had someone while I was on vacation report that they changed the card to a different slot. Things work magically. It's like, okay, cool. Next.
Yeah.
The thing is,
I
if
mean,
we want to decide that who is the way we are going it at the moment, because I didn't hear any objection from any other DPU vendor, for getting the inventory. If there is another way to do it, we can add it to the flow as a different option. If any other DPU vendor will say, this is, I don't want to support flow, I want to support something else, but I don't want to leave it as a general inventory thing, because
okay.
I would certainly like to see the through capability in place.
what do you mean by in place?
That the XPUs have a fruit. Now, I want to stop short of mandating it, but from a server point of view, and similar to Julia's comments, we don't have high level of certainty that the card is in the right slot, right? And especially in servers that have many slots, certainly the probability of installing it in a slot that was not the target is a fair amount. There's a fair amount of probability that could happen. So. And there may be some security issues as well, in terms of, we may not want to power up if a certain device is installed, or we just want to make sure the right device is installed. And there is another consideration for bare metal OS support, where the DPU needs to come up before the BIOS comes up.
The DPU needs to come up before the BIOS comes up.
Yeah.
That's an interesting statement. It is related to what I said before regarding the power assumptions. If we always, because I also had that in mind. I mean, what makes sure that the server BMC is up before the XPU, or do we dictate that maybe XPU can be up before the server BMC is up? Technically, can.
Yeah, this may not have been stated the best in this diagram, but that's what the hold enumeration is. So server BIOS would get, so maybe this should have just been server, not server BIOS, but the server gets the power on, but the BIOS, it just does maybe like the memory check or something, but it doesn't really enumerate PCIe devices. And that's to allow the XPU to completely come up before PCI enumeration.
Can
So
you
that you
repeat that
can
again? I kind of lost you in the middle.
Okay, so whatever line 6 here, I guess it is, right? Which is hold enumeration. That's hold PCIe enumeration. So basically, there's a coordination between the server BIOS and the BMC. Now, okay, what you need, okay. Basically, what we're saying, maybe, okay, what you need is you need power coming over the gold fingers to the XPU, probably to power it on. right? You know, depending on what kind of XPU is in there, if it has external power cables or whatever, right? But if you need power on the slot, then you need to turn the server on, but you don't want it to get to the point where it enumerates PCIe functions. Now you could do some of the BIOS stuff, like you could check all the memory. You know, there's several things that happen before you get to PCI enumeration, right? That you can do. But the idea is that you would hold PCIe enumeration until the XPU services are up and going, such that if you are doing, you know, classically the NVMe emulation, and you want an emulated NVMe PCIe device to boot off of, right? Then you can do that.
First of all, this diagram is getting smaller and smaller by the minute. We said that we will join the XPU manage and the CPU. Now I'm hearing to join the server BMC and the server BIOS.
No, the server BMC comes up and is on, so the BMC is fully up, right? You're holding PCI enumeration on line 6 there, right?
Yeah.
Okay, so BIOS is partially up, right? And yeah, there should be some numbers associated with these messages, and then some text that describes what they actually do, because that's what's really lacking from this diagram.
OT to myself. Probably once we conclude it, also the PLDM comment, the exact comment which we'll use. Okay, let's start at the beginning. So regarding the power assumptions that we have here, do we even want to list that as an option of the order of power-ups, or because, as you said, the row request can happen before that. We don't necessarily, and the old enumeration as well.
Yeah, I think in the original diagram, I probably just had a bar, you know, like a red line that went completely across all of them that just said power on, you know, like AC power applied, right? Or DC power, you know. It just anchored the diagram as a, you know, here's where you
Is
start.
it sequential?
Yeah. Everything's going to get power. But I mean, a server BMC can be up before DC power is on, right? So usually they are running an aux. Okay, so it you know, now you can, if a DPU has its own power domain, then it could be running an aux as well. But so that's another thing you can, that would be an optional thing in this diagram, right? Whether or not the XPU has power independent of the server or not.
So I think you said it best when you said one clear line. Maybe we should just have, as you said, one clear line here, just saying getting power, not necessarily power on or not. And this removes the whole order of what is powered before what. And if the DPU is already powered and booted, then all the other steps here are just a given, because the get boot status will just be true and will just run here, basically.
Yeah, but the idea here is that the BMC comes up before the server, okay? And then if it's configured to hold boot, right? So, you know, depending on your solution, you may not care, right? So if the server could boot independently of the XPU, and later on, you know, like if all the XPU is doing is, you know, deep packet inspection or whatever, it doesn't really matter what order things come up in, right? Or may not matter, right? But if you do care, then basically when BIOS talks with the server BMC, or it's not going to continue to boot until it gets, a positive response that the XPU is ready, right?
Okay, makes sense. Makes sense. So I'm going to leave the whole power assumptions out of the picture, basically, and just keep it as a straight power line. Regarding the whole enumeration, you did say that you don't really care if it's before or after the full request. I do think that if we are going to support anything that is not full, it should probably come before that, to leave room for things that are not as static. Make sense?
I think so. So you're saying that you want to keep it there, or you think it could move around?
I think it can move. The whole enumeration can be directly after the power on.
Right. So
basically.
it only matters that it's there if the BMC wants to verify that there is an XPU in that slot that it's going to hold power for. Like if the hold enumeration is conditional on there being an XPU, or the XPU still being in the slot, right? So, and then you have, so there's a whole lot of there.
Yeah, I think there's a dependency here that the hold enumeration, the enumeration is put on hold only if the XPU is present. And so that's why the through request and response needs to come in first. So it's conditional.
But yeah,
Okay, that makes
make
sense
that
actually.
if you didn't make that a condition and you just blindly, well, maybe you didn't blindly do it. Maybe you did it based on the last inventory you received, and then later on you do inventory and find out, oh, it's wrong. I mean, this hold enumeration probably has timeouts associated with it and failure conditions. Like if you later come up and the server BMC decides, hey, wait, this XPU is never going to boot, or there really isn't an XPU in that slot, then you could release that enumerate, whatever, right? So you can do all kinds of things, but this was kind of a first simple attempt at describing the state machine.
No, I actually really like that state machine, that sequence diagram. And the rest of the note that you gave right now is that all the enumeration is conditional. At least for me, it made a lot of sense for why we have to have that before that.
Yeah. But again, it really does need probably some numbers and a little cleanup
and some
here
more
and a bunch
details.
of words that describe what that actually means.
Yeah.
So
So I know that in NVIDIA, at least on our DPUs, we do use 4 and do provide it. Maybe a good path forward regarding if to decide to use it or not. I can provide I think I can provide the standard, what we currently give return back on 4 request, and just give it to you and server vendors to review. Make sure that you have enough to identify that this actually represents an XPU on the standard 4 that we have. And if it is enough for the coordination and no other vendor objects to it, then I prefer to decide we will use 4 unless a different vendor will come up with another method he wants to support, and then we'll take it into, we can always open this up into discussion. But because it's so critical for the old enumeration. Yeah.
I suspect there's a bit of a gap there. I mean, I think you can determine that you have a particular model of device from a particular vendor there, but you would need a whitelist, blacklist, or you need the BMC would need to add additional information to call it a DPU, if that makes any sense. I don't know if the PCIe device type is in the standard IPMI-FRU, and then I don't think there is a PCIe device type defined for XPU right now. So you might see it as a NIC, you might see it as a storage device, but you wouldn't necessarily, unless you have prior knowledge that that type of device is an XPU, you wouldn't know.
Okay, so what I'm getting from the statement is the question of how a server BMC can generically know from the standard FRU if the device is an XPU, DPU, IPU, whatnot, for all vendors.
Right.
Okay.
This is gonna sound silly, but I mean, I'm also out of my depth, but it seems like when a DPU, basically wouldn't want to be signal itself in its existence as I am basically a super smart switch, multifunction switch device that can provide other software-driven devices off of the main device. And shouldn't that be what is signaled upon, not the base function? So it seems like there's a new functions required that needs to be codified in the standards bodies. Or have I lost my mind completely?
I think we'll eventually get to it. I don't know if on the full request response, I think this is us trying to avoid it, to define like an inventory in PLDM, which you want to standardize on, and something that is.
Well, I mean, you could wait till you get to this get boot status information, and the fact that it supports it kind of lets you know, if you don't just respond back as not supported to these PLDM messages, you're like, oh, I guess it's a DPU in there, right? Or XPU in there.
Yeah, but that's an assumption by default, as you said. So if you have a different device that also doesn't, if you have a different device that does support it, unless this is specifically, of course, always an XPU. That's a good question, actually. Because that's yet another assumption.
I have another question. Maybe I might not be so knowledgeable about the PCI bus, but when you hold an enumeration for every device on the bus, right? So if you have like a PCI video card, it means it will not be enumerated, so it will not be able to load the driver. So your server will stay in the black screen until the XPU will be started. Is that the correct assumption?
I mean, you could throw some status messages on there, right? That say you are waiting on boot coordination, but
you don't have video card, right? Yet initialized with the driver.
I think so. I think you do. There is because really what I'm talking about here in PCI enumeration is you're trying to build up the boot, the boot targets, the list of boot targets, right? So I think you can get. I think you get keyboard video, that kind of stuff. Like there's like, you can have that basic functionality earlier, right? Just like, otherwise you couldn't report things like memory errors and stuff like that on the screen. I mean, I think you can do that. You can get like a very basic functionality first, just to be able to display things on the screen and handle keyboard input before you get to larger discovery of things.
Is that usually I think in some servers you get in bips, right? And in case of the video card is not initialized or something. But yeah, it's my general question because I heard what in some cases holding like having a black screen for a while may be questionable. Some customer may not like that because they don't know what's going on the server. So once we hold the enumeration, we need to make sure it's probably should show something on the screen and how it's done. That's
Yeah, well, we do that today. We have a message that says initializing DPU or something like that. With some progress bar.
okay. If it works, yeah, I'm just was curious how it works with the PCI video cards when you hold the enumeration for the PCI devices. Okay, if it works, that's.
One thing that may be missing here is that we are conditioning the hold enumeration by the through. So after we are done with the through and get to the hold enumeration, then we already know that we already know that there is an XPU there. So it can be, any device that would block the enumeration.
It can't say that it can't be any device. It has to be a device with specific capabilities or specific dependencies. Right. And Lee had pointed out earlier that there are use cases where the booting the host OS is not dependent on the XPU booting, but there are other cases where there is dependencies between the two.
Okay. So let's try to, we have like 10 minutes, so I want to at least try to cover the rest of the diagram before we, to see that the flow makes sense to everyone else. After that, we have the update boot status, which we agree that we are not going to standardize on, right? So this part is basically up to the XPU, to actually, to the XPU vendor to actually take care of. What does that mean? I think I will just unify the two into one box that says XPU, honestly, just to keep things simple. And regarding the get boot status, of course, this is something that does that we will need to push into PLDM and standardize on. Probably there are some good examples which we can take from existing devices and existing implementations here. And maybe this can be a task for the next week to check how this process is working in PLDM and how we can push to PLDM this XPU device and this get boot status function.
I have a
and
question. Gal, on this one. So how does the server BMC know when to query the boot status from XPU? Is there a specific event or a timeout? Because it holds the enumeration. After some point, we are saying it'll query the boot status. What's the criteria for triggering that event?
I don't think it's XPU specific, actually. I think it's up to the server vendor to actually decide.
Right. I agree. Vendor specific. My question is, how does server BMC determine when to do it? And should it be doing it in a loop, like multiple requests to keep checking, or?
I do know that there are certain vendors that do it infinitely. There are some that have timeouts here that says after a certain time, I'm just stopping. There are some exponential that like check after certain time, then ×2, ×4, yada, yada, yada. But maybe Reza and Lee can expand on that a bit more because they are the server vendors.
Yeah, we probably do need to standardize on that now. You know, if there are going to be multiple XPU vendors and they all have different timeouts, I don't know if that's something we need to tune for, or if we need to specify that it's required that the XPU respond positively to the boot status, or respond with a XPU ready within, you know, X minutes after power is applied or something like that. You know, PCI has this rule that PCI devices must respond 2 seconds after reset. So, you know, something similar to that concept. In terms of when does it actually start polling, we could, from a BMC point of view, we could actually start polling right after we determine that, hey, this is the target that we're looking for. This is the target XPU that we're looking for. It's installed in the right slot. And so now we're going to start polling it to until it responds with a XPU ready status. And then, you know, we certainly need to, it's good practice to have a timeout so that after some finite amount of time, if it's not responding positively, we can say, hey, you know, either reboot the server and try again, or let's raise our hand up and say, let's do some maintenance or something on the server. But I do think we need to specify the timeout. I don't know if we need to specify a polling interval. But
I
others
don't
can comment on that.
For me at least, I don't see why we need to dictate polling interval. I do think it makes sense, but I think it's up to the BMC to decide if he wants, let's say that we decide that an XPU should respond after 10 seconds. It doesn't really matter if you're just doing it once after 10 seconds or if you're doing it each second, right? It's up to the BMC to decide what to do there.
I think the initial get boot status should happen before the hold enumeration. And if the XPU returns, I'm not ready, then the server BMC needs to hold enumeration. So if the initial status is already ready, server BMC can continue booting. And if the XPU doesn't support get boot status, we know it doesn't need a boot coordination either. So this can be also as a way to detect if it is XPU or not. And if it is XPU, then we need a boot coordination or not.
That's an interesting thought, I admit. So you're saying on not only we have the full in order to detect if it's an XPU or not. So let's say we don't have the full because this XPU vendor doesn't support full, then we'll issue a get boot status. And if it supports get boot status, we know it's an XPU and we do the old enumeration. And if it does not support XPU, it does not support get boot status, then we don't do all the enumeration and just continue.
Right.
And
Basically the XPU that needs the boot coordination needs to implement get boot status.
and that does that eliminate the need for the fru?
I don't think so. I don't think it really eliminates the need for the full, but it gives us a different path, let's say, because we can have a situation where we have a full, but we don't.
Mm-hmm. That the big difference is Fru is available in VAux, an aux power, right? You might not be able to issue that get boot status command for a period of time after power is applied, right? If the XPU management takes time to become available, or so that's the only consideration you have after that. So you may have to hold enumeration before you get any responses back to get boot status, because you may not be able to send the message, or it may not respond for some time.
Yeah, I agree. There's a fair amount of uncertainty there.
What actual problem is there holding the enumeration if we understand that this is an XPU and only then issuing the get boot status? Because if it's a XPU that doesn't support Fru, then we'll just continue on. We won't do the old enumeration. We won't do the get boot status. Just treat it as not an XPU device. And I think that if we are standardizing on Fru and we are standardizing on get boot status, then situation where we have a vendor that supports just one of the two.
Well, there's some asynchronous activity happening here, right? There's the BMC activity, communicating to the XPU, and then the BIOS enumeration is sort of independent, and we're trying to coordinate these two.
So I think we need to call the get boot status and wait for the get boot status to respond. So at that time, we basically hold the enumeration because we are waiting for the response from the get boot status, and there needs to be a timeout. And if we get a response and the XPU says, I need a server to wait, then we continue to wait. And if we don't get a response, then we continue booting. And if the response is ready, then we also continue booting.
Yeah, we're at the top of the hour now. About to have to drop.
Yeah. All right.
Okay, folks. Then thank you very much for joining. I'll do a quick summary and see you next week.
All right. Thanks, guys.
Thanks.
See you.
Bye-bye.
Bye bye.